In this video, we will look at the past year paper from the A-level chemistry paper 2 from February-March 2022. So we will discuss on the question 3D, which is actually on the acid and a base chapter. So now in this question 3D, we have the question which is the hydrogen halide dissolved in water to form a strong Bronsted lauric acids. So state what is meant by the word strong Bronsted lauric acids. So since this is a 2-mark, you need to actually give a definition on what's the meaning of strong and what's the meaning of Bronsted lauric acids. So for the word strong, it means that the acid fully dissociate in water. And what they do when they fully dissociate in water to be an acid, when they dissociate in water, they donate proton. Now, the next question is actually on the acid-base titration curve. So since in this question earlier, we already know that the hydrogen halide is actually a strong acid. So we're going to titrate the hydrogen bromide with the different types of base. One is actually NaOH, which is a strong base. And the ammonia is actually a weak base. So with this, we actually have a strong base, strong acid titration curve, and a weak base, strong acid titration curve. So now we are actually given a 0.1 m NaOH. So imagine that we actually add it through a burette. So 0.1 m NaOH. And we add it to 25 cm cubes of HBr of concentration 0.1 m. Now, to complete the titration curve, you need actually a few points. So the first one, we need to actually put in the initial pH. The second one is actually the equivalence volume. And the third one is actually the pH of the vertical region of the graph. And the last one is actually the final pH. Now, for this titration curve, since we actually have our beaker is actually a strong acid, normally the pH will measure at this solution over here. So in this case, the initial pH should be a pH of a strong acid. And normally a pH of a strong acid, the pH will be less than 3. So I'll put it around 1, like this. And to find the equivalence volume is actually telling people how much volume of NaOH should I add in to completely neutralize the HBr. So to find the equivalence volume, then I will use the formula M1V1 equals to M2V2. So the M1 will be the concentration of HBr, which is 0.1, and the volume is actually 25. The M2 will be the concentrations of NaOH, which is 0.1, and we need to find how much is the volume of NaOH needed. So with this, we will see that the volume of NaOH needed is 25 cm3. So with this, 25 cm3 will be the equivalence point. And the next one is actually the pH of the vertical region. So since this is a strong acid, strong base titration curve. So a strong acid, strong base titration curve will actually have the vertical region around pH 3 to 11. So I will mark it pH 3 to pH 11. This is where we see a vertical region. And the final pH. So for the final pH, is actually the pH when you added excess of NaOH. So since this is NaOH is a strong base, so it should be a pH of a strong base. So pH of a strong base is normally greater than 12. So with this, I will mark it around pH 12 to 13. Then I'll join the graph together. So when I join the point together, the shapes of the graph, it should look like a sigmoid shape, meaning that it looks like an S shape like this. Now, the next one is actually a weak base and a strong acid titration curve. So, meaning that we actually have in our burette that is actually 0.1 m ammonia. And in the beaker, we actually have 25 cm cubes of 0.1 m HBr. So with this, again, we need the initial pH. So the initial pH, normally we take it from the solution in a beaker. So the initial pH will be also a pH of a strong acid. So I'll mark it at around pH 1. And the equivalence volume. So we see that 25 cm cube of 0.1 m is titrated with 0.1 m ammonia. It means that the equivalence volume will be 25 cm cube. So we will use the same way, which is M1V1 equals to M2V2 to solve it. So with this, we will get the volume of ammonia is 25 cm cube. Then the third one is the pH of a vertical region. So since this is a weak base and a strong acid titration. So for a weak base, strong acid titration, normally the vertical region will be towards the stronger side, which is the acid. So in this case, the pH will be around pH 3 to 7. So I'll mark it pH 3 to pH 7. Then the final pH is actually ammonia. So it's actually a pH of a weak base. So normally pH of a weak base will be less than 12. So it will be somewhere around pH 10 to 11. So I will mark it around pH 10 to 11, around here. So then I'll join the point together to get my sigmoid shape curve. So this will be the shapes of the titration curve. Then let's move on to the next question, which is actually on the reactions of the HBr with propane. So when HBr react with a propane, this is actually an electrophilic addition. Okay, and they say that it formed two bromoalkane. Okay, so why we actually get two products is because our propane is actually an unsymmetrical alkene. So when we have an unsymmetrical alkene like propene, then what we will actually know is that the HBr, which is having the H as the electrophile, okay, so the electrophile, it will join the carbon with the most H. Okay, so when you join the carbon with the most H, then you actually get the major product. So in this case, we need to complete the diagram to form the major organic product. So before that, we need to actually include the charges, dipole, lone pair. And also we need to draw the structure of the intermediate and also the major organic product. So now we need to actually label the H as partial positive, the Br as partial negative. Okay, so then after that, from the pi bond of the alkene will actually attack at the electrophile. Then we will have a heterolytic fission where we break the HBr bond. So the arrow must be from the bond to the Br. Then after that, we will draw the intermediate. So like what I said, we have this carbon number 1 and we have this carbon number 2 to actually attach with the H. But if you look at the carbon number 1, there is actually 2 hydrogen. But carbon number 2, there is only 1 hydrogen. So to get the major product, normally the H will join the carbon with the most H. So in this case, you will realize that the H will join to the first carbon because they have 2 hydrogen. Okay, and when you join to the first carbon, then you will actually get a positive charge at the carbon number 2. So we will actually say that this is actually a carbocation intermediate, and this carbocation intermediate is actually a secondary carbocation intermediate. So the next thing is to put in your Br. Okay, so your Br is now negative charge, not partial negative, it's negative with the lone pair. Then we will actually, from the lone pair, we will attack to the carbon which is having positive charge, and we will actually get our major product. Now, explain why the two bromoalkane are not produced in equal amount by this reaction. Okay, so in this case, what's the reasons why they are not produced in an equal amount? Okay, so for our major product is actually a 2-bromopropane. Okay, but the another product is actually a 1-bromopropane. So the difference between 2-bromopropane and 1-bromopropane is the 2-bromopropane, which is the product, it is formed from a secondary carbocation intermediate. Okay, but the thing about our 1-bromopropane, it is actually formed from a primary carbocation intermediate. So in this case, what we realize is that a secondary carbocation intermediate is more stable. Why is it more stable? Because they have more positive inductive effect by the alkyl group. Okay, so your point must mention about the secondary carbocation intermediate. It's more stable. And why is it more stable? Due to positive inductive effect by alkyl group. Now, the next question is actually on the reactions of the halogenal alkane with NaOH. So if I have the 1-bromopropane and I react it with the NaOH in the presence of water as the solute, so meaning that I have a CH3, CH2, CH2Br, and I add NaOH aqueous. So if I add NaOH aqueous, this reaction is actually considered as a substitution, meaning that the OH will substitute the positions of the Br. So with this, what we will get is we will get our organic compound, which is actually alcohol, and the Br will be kicked out. So the Br will join with the Na. So we will get the inorganic product is actually NaBr. So we write it down. So CH3, CH2, CH2OH, which is the propanol, and the inorganic product is NaBr. But then if let's say this reaction is carried out in the presence of an ethanolic NaOH, so the reaction that happened is actually an elimination. So in the elimination, the role of the OH is actually acting as a base. So what they will do, they will tend to actually absorb one of the H from this carbon over here. Then they will be eliminated as water. Okay, and then other than that, the Na will join with the Br. So we actually get NaBr. And in terms of the organic product, since we actually remove one H from this carbon and we remove the Br from the second carbon, from the another carbon, then the organic product that we will get is actually a alkene. So we will get a CH3, CH, CH2. And the inorganic product, it will be NaBr plus H2O.